Hello, my name is Amberly Rodriguez, and my partner is Kenya Roy, and we will be presenting the MSRP of automobiles. So just a brief overview of the project. Our objective is to help people understand how a car selling price is influenced by various features. So our approach is first an in-depth EDA. Next, we're going to utilize feature selection methods for our multiple linear regression models. And then finally, interpretation and our recommendations. Our target audience is the average everyday person who is interested in purchasing a new vehicle. Just some background of our data. Our data set is the MSRP of automobiles data set. This had 11,914 observations with 14 variables. We did notice that the variables did have a very, very large range. So for example, the MSRP, the minimum observation in this variable was 2,000 and the max was over 2 million. So this is a very large range. We decided to limit the scope of the data set because we felt it would be better focused on our target audience. So to do this, we limited the range of the MSRP to only include observations that had 10,000 to 80,000. So this resulted in a subset of the data with 9,378 observations and 14 variables. And we did conduct our entire analysis on the subset of the data. Here's a more detailed description of the data set. So we can see on the left, we have all 14 variables and their corresponding data type. We do see that we have a good mix of numeric, categorical, and factor variables, which is really nice. We have in the middle a description of each variable, and then we have the minimum and maximum. If we look at the MSRP, we see it has a min of 10,135 and a max of 80,000. Although we did limit the scope, the range of the variables is still pretty large, so we did include the median and the mean in this data description table. Next is the missing values. So this data set did have a lot of blank values, so we decided to replace those blank values with NA. So this resulted in 3,835 missing values. But upon further analysis, we noticed that market category had approximately 29% missing values. This is because this column had over 3,000 blank values. So we decided instead of replacing those blank values with NA, we will just create a new category within the market category column, which is unknown. So that way we keep the integrity of the data. After dealing with the market category column, we had 92% missing values. We had 92 missing values. That's what we see here on the left. We have the percent missing for each variable. So we can see that each variable has less than 1% missing value. Again, in our investigation, we noticed that the type of missingness was MCAR, or missing completely at random. We did not uncover any trends that would lead us to believe otherwise. Due to the type of missingness and the low percentage, we decided to drop the missing values from the dataset. All right, now I'm going into the EDA. Here, if we're looking at a histogram of the MSRP, we do notice that a majority of the observations are between 20,000 and 40,000, and it is slightly right skewed. Here we created a correlation heat map. So we wanted to see how correlated the numeric variables were to the MSRP variable. So we can see here that the year variable is slightly correlated positively. The engine.HP is highly positively correlated with MSRP, and then engine cylinders is pretty correlated to MSRP as well. We see here that number of doors is not very correlated at all. And then we see that highway MPG and city MPG are negatively correlated to MSRP, which is as expected. Here we are looking at a scatter plot of the MSRP by of MSRP versus the MPG by the engine fuel type. So each different color represents a different engine fuel type. Here we see that this 20,000 range is really dominated by the regular unleaded fuel type, which is to be expected. Majority of cars are regular unleaded, and we do see a lot more pink. When we look at the higher MSRP values, it is interesting because we do see a pretty good mix. No one color really dominates the MSRP around the 60,000, 80,000 range, which is very interesting. We created a similar visualization, but instead we colored it by make. So again, we have the MSRP versus the highway MPG, and each color here represents a different make. The next slide, I will show all of the different makes, the legend for that, but I just wanted to highlight here that we really see a mix of the colors. There's not a one color that dominates any section of this graph, which is super interesting. And here's just the legend from the previous graph. We also created a box plot of the MSRP by make just to do some further investigating. And here we do see that there is a big fluctuation between the averages of the different makes for the MSRP, but we notice that there are quite a few observations that are not within their averages. For example, if we look here at Ford, we can see that the average is around 30,000, but there are so many observations that are outside of that average, which is very, very interesting. So here we're going into objective one, which is the modeling part. So here our goal is to predict the MSRP using those variables that we just looked at from the automobile data set. So we did use stepwise feature selection, and this resulted in these suggested variables. So they suggested make, year, engine fuel type, engine HP, engine cylinders, transmission type, driven wheels, market category, vehicle size, and vehicle style. So we took into account these suggested variables and also the knowledge we gained from the EDA, and we concluded with a final model. So that final model is predicted MSRP equals make plus year plus engine fuel type plus engine.HP plus engine cylinders plus market category. So with this model, we had an R squared of about 84% and adjusted R squared of also 84%. Our p-value is very, very, very small, so we know that this model is very statistically significant, and an F statistics of 476.2 and an RMSE of 4,782.97. So this is our first multiple linear regression model, and Kenya will take us into objective number 2, where we compare the model against more complex models.
And thanks to Amberly for starting us off with the EDA and going through objective 1. So now we're going to start with objective 2. I'm Kenya Roy, and I am ready to get the ball rolling. So along with the multiple linear regression that Amberly walked us through in objective 1, I went ahead and pulled together a complex version of the multiple linear regression in a KNN model. We'll walk through these models and then we'll compare them and see which one best fits the data set that we were given. So before we really move into the models themselves, we decided with the complex multiple linear regression, we wanted to make sure that we were careful about picking the variables that went into the interactions that we wanted to choose, and we did choose to include interactions in our model. So we were careful not to include interactions between variables with high correlation, and you can note those in the correlation matrix and heat map that was included in objective 1 in the RMD. And so we used our domain knowledge to do this. So Knowing the common characteristics that car buyers concern themselves with when looking for a car, we know that make and year have an impact on MSRP. We also know that engine horsepower and year also have an impact on MSRP. And the key variable year that's included, um, it's highly influential because over the time, since the 90s, cars have gotten very expensive. So we'll see that with the 3D scatter plots that we created. Um, so looking at the 3D scatter plot for make and year, you can see that with the makes and with the passage of time, the MSRP rises. And for a little bit of explanation as to what's going on with the legend on the side, um, all of the makes are included here, but there are over 35 makes that were included in the data set. For ease of visualizing the data here, we decided to just highlight the American cars. And if you want to look at different makes and models, or just makes, you can use the RMD file to select different makes. You can select all of them or just one. It's very interactive in that way. So we'll look at the scatter plot from a different angle to see just how much the MSRP rises over the years with American made cars. So the other interaction that we want to look at was year and engine horsepower. And just as we saw with the make and year, over time, the horsepower increases and so does the MSRP. And we can see that with another angle. So we will look at how the multiple linear regression performed with the more complex model. And that more complex model, of course, included two interactions, make and year and engine horsepower and year. So the R squared value was high, it's 8.53. Adjusted R squared is 8.507. P-value is great, the F statistics great, and the RMSE is low. So why we didn't choose to use just one interaction variable? Why did we decide to use two? So with the interaction variable, we decided to use, when we used just one interaction variable, we saw that the adjusted R squared was lower, the AIC was higher, so was the BIC and the RMSC. So the model that had two interactions outcompeted both the original model that Amberly pulled together and the interaction with just make and year, which was the strongest interaction we could pull together with our domain knowledge. So moving forward, we decided to use the model with the two interactions. And working with the KNN model. So basically, we used the data set and trained a subset with 80% of the data set, and then the other 20% was used for testing. With five-fold cross validation, we got these performance metrics. So the R squared was 8.6895. And the adjusted R squared was 8.8875. And both of those metrics, including the RMSE, outperformed the complex model that we just went over. And that's for a very good reason that we'll get into while comparing the models. So comparing the models, as I previously mentioned, the complex MLR model outperformed the multiple linear regression model with the use of two interactions. And then the KNN model outperformed both of those models. And reasons why the KNN model outperformed, I can say definitely that the KNN model is less influenced by multicollinearity. With this data set, we had a lot of variables that were highly correlated, and that those variables definitely influence what our models look like. And while we were able to use stepwise or feature selection to get our best fit models, and then also interactions to enhance the ability to predict MSRP. The KNN model doesn't need explicit, identification of influential interactions, and doesn't need to use linear relationships to create the best predictions. So the KNN is more flexible in that way, and I think that better suits this data set since there are so many um, variables that could create some multicollinearity in the models that we wanted to create. Also, another reason why the KNN model outperformed is because the KNN model doesn't work on the assumption of linearity, normality, or homoscedasticity. So it's more robust in that way, and it gives us a stronger prediction of the MSRP with our data set. So, in conclusion, we definitely recommend using the KNN model that we created to predict MSRP using the MSRP data set, the reduced data set. And we can say that in terms of being able to apply this to the general population of automobiles, that isn't necessarily the case here because we don't have enough information about where this data set came from, how the data was included, was it random? Um, None of that was included, so we can't really apply what we've inferred here to any other larger set of data. So there's that. But we would say if we had more time, it would be interesting to look at some relationships between um, the automakers themselves, the countries that they belong to, if there are any relationships between, um, cars made and developed in the US as opposed to Germany or the United Kingdom or Japan. That would be something that would be interesting to look at if we had more time. But um, we know that you're mainly concerned with finding out which model best predicts the MSRP, and we know for sure that the KNN model is the best model to move forward with. So, if you have any additional questions or concerns, feel free to reach out to me or my partner, Amberly, and we thank you. Thank you so much.